Okay, so this is the third video in the playlist where we're looking at the 2017 Paper 2 calculator for Edexcel. In the previous video we finished at question number 15, so from this video we're going to carry on with question number 16 onwards. I'm going to aim to get to the end of the paper if I can, and hopefully take around about half an hour to get there, so hopefully it should give you about an hour's worth of focus revision if you download the paper from the description and have a go at some of the questions for yourself. Okay, so let's move on then to question number 16. Using algebra, prove that 0.136 recurring times 0.2 recurring is equal in value to 1 over 33. Okay, so really what they're saying is that we need to work out the fraction equivalent of that, and then multiply the two together. So it seems a little bit trickier than it actually is, but hopefully you'll be able to follow me on this one. So what I'm going to say is let n equal 0.1363636 recurring. Okay, now if that is the case, then I can also say that 100n equals, if I move the decimal point, that's going to be 13.636363, okay, and that carries on. And then I can say, well, if I take n away from that, what I end up with is being able to get rid of all of the recurring element of this particular decimal. So if I take one away from the other, I end up with 99n, and that's 13.6 take away 0.1 is going to be 13.5. So therefore I can actually write this as being, if I divide through by 99, that n equals 135, or beg your pardon, 13.5 divided by 99, which is exactly the same as saying n equals 135 divided by 990, just by moving the decimal point. Now, in your calculator, because this is a calculator paper, what it'll actually do is it will reduce that down to a much easier fraction, which is 3 over 22 to deal with. Okay, so let's look then at 0.2 recurring. Now, in this particular case, I'm going to say 10n equals 2.2222, and n equals 0.2222, okay, and those carry on. Now again, if you're not sure about this particular type of technique, please do have a look at some of the playlists on the channel, and this will help you with these sorts of questions. So if I take one away from the other, I end up with 9n equals 2, so therefore n equals 2 over 9. Okay, so in this case, now what I've done is I've changed this 0.136 recurring and this 0.2 recurring to two separate fractions. So it is then just a case of saying that if I'm going to multiply those two together, then I'm going to get 3 over 22 multiplied by 2 over 9. Pop that into your calculator, you're going to get 6 over 198, and again that will actually reduce on your calculator to 1 over 33, and that's the proof to this particular question. Hope that's okay for you. Let's move on then to question number 17, and question number 17 deals with a sector of a circle. Okay, now there's a little bit of work to do on this particular one, but what we're saying is that we have a circle where we've got, in this particular case, and it's very important, we've got this equilateral triangle of side 7. So what we're saying is this is 7, this is 7, this is 7, and this is actually 60 degrees, okay, because the internal angles of an equilateral triangle are 60 degrees, and we can use that to actually work out the whole area of, well, we'll call it ONQ. So it's actually this whole segment. Is it a segment or a sector? I can never quite remember, but it's sector, I think it is, this whole sector around here. Okay, so that's going to be 60 over 360, which is the fraction of the circle that we're trying to work out the area of, which is using the formula pi r squared. So if we pi r squared, so if I pop that into then using the radius of 11, I get 60 over 360 multiplied by 11, pi times 11 squared. Okay, and you can tell here it does say the circle has a radius of 11, so I can use 11 squared for this particular one. Okay, pop that into your calculator. You're going to end up with 121 over 6 pi. Now, if I were you, I would just kind of leave it like that, because it's just much easier to deal with these sorts of questions when you've got a relatively simple fraction to deal with. You could, if you want, put it down as a complete decimal and write it all down, but it just doesn't look as neat when you're actually working through the solution. Okay, so then let's look at the area of this equilateral triangle. Okay, well, one of the formulas that you need to remember is the area of, in this case we'll call it ABO, is a half AB sine C. So this is the area of a triangle. So you could, I guess, work out the height of the triangle and do half base times height. But if you do remember this formula, it will make your life a little bit easier, because then you can just work it out straight away as a half times 7 times the sine of 60 degrees. And again, if you work that out, that's going to give you 49 root 3 over 4. Okay, so we've got our two values here that we can then use to work out the area of the shaded shape. Okay, because what we're looking at really is how much ABO is out of ONQ. Okay, so if we do that, we can just simply use our calculators to divide these two fractions, or these two numbers. So we've got 49 root 3 over 4 divided by 121 over 6 pi. Okay, now I know that looks a little bit difficult, but if you just pop that into a calculator, that will give you an answer. Use the fraction keys and just make the calculator do a little bit of work for you, and that's going to give you an answer of 0.3348. Okay, so bearing in mind that that's the fraction ABO, so it's the fraction of this triangle out of the overall sector. Okay, so therefore if we want to know the area of the shaded region, so the area of the shaded region, okay, well that's going to be 1 minus the answer. Okay, so it's actually this whole shape minus 0.3348, and if we multiply that by 100, that's going to give us it as a percentage, because it does ask right at the top of the screen there for the percentage of the area. Okay, so that's going to give you an answer of 66.5% to 1 decimal place. Okay, I hope that's okay for you. It does take a little bit of time to work through these sorts of questions, and I do absolutely understand at this sort of level you need to be really have a lot of these formulas at your fingertips and feel confident in using them. Okay, so let's move on then to question number 18, which deals with working out some indices. Now, this particular one, again, a little bit tricky, but what we're basically saying is that we've got 16 and 1/5 multiplied by 2 to the power of x equals 8 to the power of 3/4. Okay, well, what I'm going to do is I'm going to change that around a little bit, because we're essentially what we've got, we need to make these all to base 2. Now that one in the middle is okay, but we need to worry about that one and also that one here. So rather than writing 16 to the power of 1/5, I'm going to write 2 to the power of 4 to the power of 1/5 multiplied by 2 to the x equals, and rather than writing 8, I'm going to write 2 to the power of 3 to the power of 3/4. Okay, now I'm in a position where essentially I can then work that through. So let's have a look at this 4 to the power of a 5th. Well, that's the same as saying 4/5. Now, bearing in mind what we are interested in is just these indices. So I'm not going to worry too much about these base 2's because I've got all that information now. So what I can say is that when you multiply indices together, you add them. Okay, so 4/5, which is this indice here, plus x is going to be equal to this indice here, which is going to be 9/4, okay? And then really it's just a case of dealing with the fractions. So in order for me to work out x, I'm basically going to work out 9/4 minus 4/5. Now, as you know, when you're dealing with fractions, you need to make sure that the denominator is the same. Okay, so I'm going to make both of those over 20. And that will give me 45 minus 16 over 20, which is going to give me 29 over 20. Now actually that is the correct answer. However, writing this value of x to 29 over 20, that would work fine because it is the correct answer. However, you might just want to convert that to a decimal of 1.45 because it looks a little bit neater. So that's fine. Hopefully you're okay with that. Bearing in mind, they're not asking us to solve this, so you don't need to worry about actually the multiplication and working all that out. You might as well just go right ahead and deal with the actual indices themselves. Okay, on to question number 19. And question number 19, it's just awkward really. It's just one of those questions where you've just got to grind your way through it. There isn't really an easy way of doing this. It's just providing you're okay with working through algebraic fractions and making sure that you've got the same denominator, it's just really a grind is all of this particular question, because you've got to make sure that they're all under the same denominator, which is x minus 3 multiplied by x plus 3. So this 2, well, bear in mind that that 2 is the same as really saying 2 over 1, okay? So I can then write, if I want to make sure it's got the same denominator, I've got to multiply the top and bottom by x minus 3 times x plus 3, and then x minus 3 times x plus 3 at the bottom here. Okay, so that deals with that too. And then I've got the next one, I've got x plus 2. Okay, so that's minus. Now, I am very aware, I know I normally with these, I put square brackets around. I probably will do in the next line, but I'm very aware of these negatives that we've got going on in here. And you'll see that I will make some adjustment for those when we move on a little bit. So this one is x plus 2. Well, that's going to have to be multiplied by x plus 3. And that's divided again by x minus 3 times x plus 3, okay, and then I've got this minus, and the last little bit is going to be x minus 6 multiplied in this particular case now by x minus 3, and divide that by x minus 3 times x plus 3. So therefore I've now got all of these denominators looking exactly the same, so I can write everything under one big long line of x minus 3 times x plus 3. Now you will recognise that as being the difference in two squares, and we will come to that in a couple of minutes. Okay, so let's have a look at this one here. X minus 3 times x plus 3, well, that actually multiplies out or expands out to x squared minus 9. So I can write 2 times x squared minus 9. Okay, that's the first little bit. Second little bit, now this is where I'm going to put this into square brackets because of this minus sign. Okay, and I'm going to get x squared plus 5x plus 6. Close the brackets off, minus, open up some brackets again, and I'm going to get x squared minus 9x plus 18. Okay, so just be very careful about the negatives in this particular type of question. All right, so when I remove the brackets, what I end up with is going to be 2x squared minus 18. Well, that's all right. Minus x squared, and remember this minus has an effect on these two terms, so it's going to be minus 5x minus 6. As does this minus, I got minus x squared plus 9x minus 18, and all of that, I'm going to write this now as x squared minus 9. Okay, so actually the bottom, the denominator, is the same as what they're asking us for, which is fine. And then really it's just a case of tidying this up. It's just, you're just going to be careful with it really. You'll see here that I've got 2x squared minus x and minus x, so I'll get rid of that. And then I've got minus 5x plus 9x is going to give me 4x. Okay, and then I've got minus 18 minus 6 minus 18 again is going to give me minus 42, and that's divided by x squared minus 9. So although it looked a bit awful to begin with, it's just one of those questions where you've just got to grind your way through it, and then hopefully towards the end of it you will get the final answer. Okay, let's move on then to question number 20. Okay, so we're going to move on now to question number 20, and what it says is the diagram shows part of the graph of y equals x squared minus 2x plus 3, and by drawing a suitable straight line, use your graph to find estimates for the solutions of that. So what we're basically saying is that if we're finding solutions, it's where the two graphs cross each other, so one must equal the other. So I can write that as x squared minus 2x plus 3 equals x squared minus 3x minus 1. Okay, now what actually happens with this is that when I start to solve this or work this out, I end up by taking this x squared over to this side and it cancels itself out. So I then bring this minus 3x over to the left-hand side and it becomes plus 3x, so I get x. And then I've got this minus 1, I bring that over to the left-hand side and I get plus 4 because I'm adding that to the plus 3 here. Now that particular point, that's what we're saying, is that really what I can do is I can draw this line of y equals x plus 4, okay? Because if I draw this line, it will then give me the solutions to the graph to find estimates for the solutions of the two. Okay, so it's the graphical equivalent, if you like. So I can draw just a little grid like this, and I've got values of x, and I can choose just whichever values I want. 0, 2, 4, something like that is perfectly fine. And because I know it's going to be a straight line, I'm not too concerned about having lots and lots of points to deal with. Okay, so in this particular case, what I can do then is I can draw a line at 0, 4, 2, 6, and 4, 8. Okay, now if I join up that line, what I've got then is, I just need to get my ruler. I've got then this particular line that looks like that, okay? And that means then that I can just read off the solutions of where it crosses. So that's my two solutions. So the first one is going to be this one here, which is going to be the value of, I think, about x equals minus 0.3, and then the final one is going to be this one here, which I think is going to be a value of plus 3.3. Okay, hope that's all right for you. Okay, next one is, it says P is a point of the graph, which is back to our original graph, this one here, where x equals 2. Well, that must be then x equals 2 is this point here. Calculate an estimate for the gradient of the graph at point P. Well, really all we're doing is we're just drawing a tangent at point P. Now, your tangent will be slightly different to mine. Okay, I tend to just, because it's on the video, it's just a little bit harder. But what I can do is I can draw a little right angle triangle here that will allow me to calculate effectively the difference in x, difference in y divided by the difference in x. Okay, so in this particular case, although I've drawn that particularly well, I've got a difference in y here and a difference in x here. Okay, so that will give me the gradient. So the gradient equals difference in y divided by difference in x. Okay, so the difference in y is going to be the difference between, hopefully you can read this on here, it's that difference to that difference, which is going to be 4.4 minus 1 divided by the x difference, which is going to be the difference between 3 and 1 there, which is going to be 2. So 4.4 minus 1 is 3.4 divided by 2, and that will equal 1.7, and that would be the gradient for this particular point P. Now, if you have a look on the marking scheme for this, it will give us a range of between 1.6 and 2.5, so it's absolutely fine, but really what you're doing is just demonstrating to the examiner that you understand that it is a gradient, and you're just drawing it onto the graph. Okay, let's have a look then at question number 21. Question 21 has got these 3 identical circles inside a rectangle. Each circle touches the other 2 circles' size of the rectangle as shown in the diagram. Okay, so essentially what we've got is we need to work out the area of the rectangle. Okay, well, let's just have a look at that for a moment. So what I can say is because the radius of each of the circles is 24 millimeters, then I've got this situation where that is 24, that's 24, and then I've got this along here and this along here, where this is 24, 24, 24, and 24. Okay, so essentially, if I want to actually work out the height along here, okay, if I want to work out this, then I can use Pythagoras. Now, the reason I want to do that is because essentially what I've got is I've got 24 at the top here, which is the radius of this. Then I've got this height that I'm going to work out, and then I've got another 24 at the bottom here, which is this radius along here. So that will allow me then to be able to work out the height of this particular rectangle. Okay, so let's have a look at that then, because what I can do is I can use Pythagoras to be able to work out this vertical height, because what I end up doing is saying, well, actually, I know that the hypotenuse is 48. I know it's a right angle triangle because I've just drawn it, and also I know that the radius is 24. So I've just drawn this the other way around, but essentially it's this triangle here. Okay, now I can use then Pythagoras to say that actually then that must be 48 is squared is equal to 24 squared minus whatever this is squared. Okay, and eventually I'll work that out to being 24 root 3. Okay, so in other words, this height here is 24 root 3. Okay, so however you do that, I don't want to spend too long, but you'll be able to do that on a calculator without too much of a problem. Okay, so essentially what I get then is that this bit in here is 24 root 3. So now I've got the dimensions of my rectangle, where I've got this height is going to be 48, which is these 2 lots of 24, plus 24 root 3. Okay, so that's my height. And then my width of the rectangle is going to be 24 plus 24 plus 24 plus 24 again. So that's actually going to be 96. Okay, and if I multiply those two together, I'm going to get an area of equal to 864 millimeters squared. Okay, now it does say in the question, give your answer correct to 3 significant figures. This is my 3rd significant figure. It's going to change because of the 8 after it. So to 3 significant figures, it's 860 millimeters squared. Okay, and that would be 3 sig fig. Okay, hope that's all right for you. Let's move on then to question number 22. And in question number 22, we have a quadratic sequence. Okay, so quadratic sequences, there is a couple of different methods of doing this. I tend to just do it in a particular way, and again, if you have a look at the channel, you'll be able to have a look at the playlist on quadratic sequences. But basically we've got this 4, 11, 22, 37, 56. Okay, so the difference between each of these, the first difference is 7, 11, 15 and 19, and then the second difference is 4, 4, 4. Okay, that's brilliant. Well, bearing in mind that what we're trying to do is we're trying to put this into the quadratic form, which is an squared plus bn plus c. So I need to find out the value of a, the value of b, and the value of c. Well, in this particular case, the value of, this is the value of 2a. So I'm going to say that a is going to be equal to 2, because if that's 2 lots of a, half of that is going to be 2. Okay, the next bit I do is I remember that there is a little formula, 3a plus b, and that equals this first number. It's the difference between 11 and 4, which is 7. So now, because I've got this value of a, I can plug this into here, and 3 times 2, which is 6, plus b equals 7. So b must equal to 1, because that's 6. Take it from both sides, and b equals 1. Okay, so that value here is 1. And then the final thing I remember is a plus b plus c equals the value of the first number, which is 4. Okay, so the two numbers I'm interested in are these two numbers here. Okay, so I've got the value of a, which is 2. I've got the value of b, which is 1, plus c equals 4, so c must equal 1 as well. So that's the final jigsaw piece. So I can now write that out as a quadratic sequence of 2n squared plus 1n plus 1. Okay, in practical terms, we don't really write this 1n. What we do is we just write that as 2n squared plus n plus 1, and that would be the answer to this question. If you're not sure about any of that, please do have a look on the playlist on quadratic sequences, and that will give you those formulas, and there's quite a few different examples on the playlist that deal with that. Okay, let's move on then to the final question on this particular paper, which is going to be question number 23. Now, question number 23 looks a bit scary canary, because you've got this awful p, which has got an x coordinate of 3 over 2, and then a y coordinate of root 7 over 2 is a point on L. Find the equation of the tangent to L at point P. Okay, well, what I need to do firstly is I'm going to draw a little sketch, and that'll help me then just to orientate myself as what's going on with this. So if I draw this circle, now, I know that it's x squared plus y squared equals 4. Well, 4 is actually r squared. So what I do know is that the radius of the circle is going to be 2. Oh, what a dreadful circle. Okay, so the radius is going to be 2. Okay, sorry about that, looks a bit squashed. But it also then allows me to say that this is the point P on the radius of the circle, and it's at that point, which is an x value. This is the x value here of 3 over 2, and a y value of root 7 over 2. Now I'll just blow that up a little bit and just write it a little bit bigger, because it's important that we work out the line OP. Okay, so the line OP, okay, well, essentially what I've got is this, where I've got a radius of 2. This difference in y over here is going to be root 7 over 2, okay, and this difference in x is going to be 3 over 2. Okay, so I can use that to be able to work out the gradient, because remember that I need to write this as y equals mx plus c. Okay, that's the standard form of a straight line. So the gradient is going to be the difference in y divided by the difference in x. So essentially I've got this pretty horrible thing really, where I've got root 7 over 2 divided by 3 over 2x, okay, and that's going to be plus c. Now, if I put that into my calculator, what I actually end up with is y equals, now root 7 over 2 divided by 3 over 2, well, that's going to give me root 7 over 3x. Okay, now this value of C is actually the y-intercept. It's where it actually crosses. So if you remember from my sketch, it actually crosses at 0. So actually, this value of C is going to be 0. So the equation of my line is y equals root 7 over 3x. Okay, now, essentially, if I want to work out the tangent, so it's this tangent that comes along here like that. What I need to remember is the tangent, which is, let's call it the line PX, okay? So now we've got line PX. Okay, we've got to essentially remember that it's going to be the negative reciprocal of this gradient. So the gradient of the line OP and PX, well, PX is going to be the negative reciprocal of this. So it looks a little bit complicated, but actually we can write that as y equals, now rather than writing root 7 over 3, I can write that as minus 3 over root 7 x plus c. Okay, now then it's really the point where I need to find out this value of c. And the way I can do that is I can actually say, well, I know this value of p, so I can say that at p, the value of y is going to be root 7 over 2. And that's going to be equal to minus 3 over root 7 multiplied by the value of x, which is 3 over 2, plus c. Okay, and if I kind of work my way through that sort of stuff, okay, I'm going to get this situation where I've got root 7 over 2 equals, now I've got that, so I've got minus 3 times 3 is going to be minus 9, and I'm going to get, well, if I put that into a calculator, I'm going to get minus 9 root 7 over 2, because over 14, beg your pardon, because what that'll do is this will work out for me in the calculator. So I appreciate that that's a little bit untidy. I was trying to do that by a little bit of mental arithmetic there, but it didn't kind of work out for me. But because of the pressure of the video, so if you do pop that into a calculator, just use the fraction key and that will work out for you. So it's going to give me my value of c when I add this onto this. What I end up with is c equals 8 root 7 over 7. Okay, so now I can put all of this together and I end up with my gradient, which is that, and my value of c, which is that. So I can write the line px is y equals minus 3 over root 7 plus 8 root 7 over 7. Okay, now I must admit, when I first calculated this, I was really surprised by the answer and thought I'd got it really wrong, but actually that is the correct answer. So for question number 23, like we've done in the previous papers, if you get to this point, you very much deserve to get a very high level in your GCSE. So I hope this whole playlist has been useful to you. Please do add a comment below, subscribe to the site. If you get any problems, I'll always come back to you, and I'll look forward to seeing you inside the next video.